Hello, this is my final project for data mining applications. That is me, Zahn. The point of this assignment is to train and test different classifier machine learning models to see which performs most accurately by correctly identifying which, in our case, activity is being performed. And then we will also perform a comparison among the different models that we are testing. And we'll be evaluating these 5 different classifier models: naive, Bayes, random forest, decision trees, logistic regression, as well as SVM. We have 6 activities. That's walking upstairs, walking downstairs, sitting, standing, and laying. These are our dependent variables. This is what we're aiming to predict. And we are doing that based on these 5 independent variables or attributes. We'll use these to try to predict our dependent variable. The questions that we'll answer in this project is based on our 5 independent variables, what dependent variable is occurring? Or in layman's terms, what activity is occurring walking upstairs based on the attribute data we collected. And those are, again, independent and dependent variables. And then what classifier best predicts which activity is occurring based on our training data. So out of the 5 classifier models that we saw, which one is the most accurate? But first, we have to split the data. So we were given 2 files containing our training data and another file giving our testing data. So xtrain, ytrain. Xtrain is our independent variables, and our ytrain is our dependent variables. And we'll use these to train the model. Again, xtest are independent variables, ytest, dependent variables. But instead of training the model, we're going to test how accurate the model is. First, we're going to look at the naive Bayes theorem classifier. So this algorithm is based on conditional probabilities, and it uses Bayes' theorem, a formula that calculates a probability by counting the frequency of values and combinations of values in historical data. It finds the probability of an event occurring given the probability another event has already occurred, and calculates the probability of B given A. So it counts the number of cases where A and B occur together and then divides it by the number of cases where A occurs alone. At the end, the naive Bayes theorem was 77% accurate. Moving over to the coded section of naive Bayes, we're importing Gaussian NB, that's our naive Bayes classifier. And we have to assign a variable to this classifier. So NB will now equal Gaussian NB, our classifier. nb.fit x underscore train y underscore train. This tells Python that this is what we want to train this classifier on. nb underscore predict equals nb.predict x test. nb predict will be our predicted y's. So we're telling Python to predict these y's based on this testing data. Our x test, again, we know that these are our independent variables. nb underscore score equals metrics.accuracy underscore score y test nb predict. That's saying give us the accuracy. Our y test is our actual data. These are our actual y's, and compare that to what we predicted. And we can see the accuracy here is 77%. Going down, this is just a full look at the data. The diagonals on this confusion matrix are our true positives. So that means the classifier correctly identified which activity is happening. So we can see activity 0 was predicted 323 times, and those were correct. We want to see the most yellow and green. We can see those are the best there. We want to see most of those on the diagonal again because those are our true positives. And we did this by confusion underscore matrix equals metrics.confusion underscore matrix y test, again, our actual y's, and b predict our predicted y's. And this just, again, displays the information in a more visual way. Next, we'll take a look at our decision tree classifier. A decision tree classifier Like naive Bayes is based on conditional probabilities, but unlike naive Bayes, it generates rules. And a rule is a conditional statement that can be understood by humans and used within the database to identify a set of records. The decision tree classifier was 86% accurate, and down below you can see a very simple diagram of how a decision tree classifier works. Moving over to the Python code, we are assigning our decision tree classifier a variable. In this case, we named it DT. And we're training that classifier on our X train and Y train. So this is telling the decision tree model to use X train, Y train to train it. Next is DT underscore pred, and that is our predicted Y. So it's predicting this based on our X test, which is our independent variables. So DT score equals metrics.accuracy underscore score, Y test, DT predict. It is now comparing our actual Ys to our predicted Ys, and we can see that the accuracy here is 86%. Down below, we see a visual representation again in the confusion matrix. The diagonals are the true positives, so we hope that those have the highest numbers there. Again, we predicted activity 0 was happening, and it actually was happening 537 times. And this is just a visual representation of how well our classifier worked. Next, we will look at our logistic regression classifier. And logistic regression is a statistical analysis method to predict a binary outcome, such as yes or no. In our case, it's our different activities based on prior observations of a data set, and that's our training data. A logistic regression model predicts a dependent variable, again our activities, by analyzing the relationship between one or more existing independent variables, again our attributes. And then this classification method uses regression as an internal component, but regression does not come up with a binary outcome, which is why it just uses it within logistic regression. Logistic regression was 95% accurate, which is a step up from our last two models that we have seen. Moving over to the Python code, we're importing logistic regression. Again, log R is our variable we're setting to our model there. We are fitting our model with our X train, Y train data, log R underscore predict. We are predicting our Ys given our X test, and then comparing the scores, which Y test, our actual Ys versus log R predict, our predicted Ys. Again, we can see that it's 95% accurate. Looking down to the confusion matrix, we see a little bit more yellow in our true positives, which makes sense because this method was a little bit more accurate than our previous two. Next is our random forest classifier, and this is an ensemble learning method for classification. It operates by constructing a multitude of decision trees at training time, and the output of the random forest is the class selected by the most trees. So this combines the output of multiple decision trees to reach a single result. And random forest was 92% accurate, and as we could see, it was more accurate than our decision tree classifier. We are again assigning the variable RF to our random forest classifier, fitting it with our training data, predicting our Ys, and then comparing our actual Ys to our predicted Ys. The accuracy score here was 92%, so it's not as accurate as logistic regression, but we're still up in the 90s. Again, we can see more yellow, a little bit more green as our true positives on the diagonal there. The last classifier model was our support vector machines classifier. And support vector machines classification is based on the concept of decision planes that define decision boundaries. A decision plane is one that separates between a set of objects having different class memberships. SVM finds the vectors, support vectors, that define the separators, giving the widest separation of classes. And SVM classification supports both binary and multi-class targets. However, we know in our case we are looking for binary targets. And this classification method was 95% accurate, so around the same as logistic regression. Moving over to the code, we are assigning the variable SVC to this model, fitting it with our X-train and Y-train, predicting our Ys given our testing data, and then comparing the scores. Comparing our Y-test, which is our actual data, to our predicted SVC. And as I said, the accuracy score was 95%. Looking down to the confusion matrix, again, we can see more yellows, more greens, because this method was one of the most accurate right next to logistic regression. So we should see an increased amount of true positives. So our answer, which classifier best predicts which activity is occurring? Which classifier was the most accurate? Naive Bayes with 77% came in last. Decision tree, 86%. Random forest was 93%. And then our classifiers that were the most accurate, both with a score of 95%, was our logistic regression and SVMC. This won't always be the case. These just happened to best predict our outcomes based on this data. And here's my conclusion just for the overall course. I think we learned basic Python, which I found very helpful in some cases, the different types of machine learning methods, as well as how to code those different machine learning models in Python. I found this very helpful as I work with machine learning every day in my day-to-day job. And I know how to manipulate the Python scripts, but this really gave me a more in-depth look of how the machine learning is actually working, how to train the data, how to test the data. And it's increased my ability to be able to communicate to that to customers, which has been very helpful. And these are just the links to where I got some of the definitions for the models. Thank you.